This is R.D. Sharma Solution Class 12 Chapter 19. Exercise is 19.9. Indefinite integrals we are talking about. Now it's very clear in this question that x cube will give you x square and e raised x cube will give you e raised x cube. So from here we'll take this t as e raised x cube. So this dt by dx will be e of something will be e of that thing only, ex cube. Differentiation of x cube will be 3x square. So what is the benefit? This x square, ex cube, and then the dx, this one. So this is all we can get as dt. So this integration will be, let's bring dx here, and there will be 3 on the denominator with dt. It will be dt by 3 and all other things on the right, e raised x cube, x square dx. So only cos t will remain. Dt by 3 you can write like this, and cos anything will have a direct integration. This is cos t. So this cos t integration will be sin t. 1 by 3 is already there, plus constant of integration. So the final result will be like this. 1 by 3 sin ex cube. Now keep it in the bracket and then add a constant of integration. So this is your final result. Now this is the way you have to do. Please remember, e raised x cube will give you directly the other results. Here we have x square plus 3 and sec cube. So this x square plus 3 will definitely give you 2x. So we have it. But what to put tan as t or sec as t? Because tan will give you sec square. So one sec has to be separated out. So what we'll do here is sec cube can be written as sec square x square plus 3 and then sec x square plus 3. That is how we have written sec cube. And what about this 10x square plus 3? And all other things you can write it here, 2x dx. Now why it has been done? Because when we write sec x square plus 3 as t, we'll get dt by dx as sec x tan x. That is the differentiation. So sec x square plus 3, 10x square plus 3, and then the differentiation of x square plus 3 will give you 2x. So this dx will go on the right. So this dt, all of these content will be dt. So this is 2x, sec square you already have. We will not deal with that right now. But all of this is going to be dt. And since we have taken sec x square plus 3 as t, so directly t square will come because sec square x square plus 3 is already there with us. So t square dt, it will be t 2 plus 1 divided by 2 plus 1, t cube by 3 plus constant of integration. This t is sec x square plus 3 and you have to cube it. So it will be sec cube x square plus 3, 1 by 3 will come here plus constant of integration. That will be a final result. Now how to write it is again important. So for that you can follow this scheme which is shown here. Just one thing is sec cube will be written as sec and sec square. Now x plus 1 divided by x and x plus log x whole square. Now x plus log x will directly give you x plus 1 by x. That you already know, we have done this question in the previous exercises. So we'll take this t as x plus log x, dt by dx will be x will be 1, log x will be 1 by x. So when you resolve this, it will be x plus 1 divided by x, and this dx will go on the right, dt will remain like this, this whole will be dt, and x plus log x will be t square. So let me write it here. It will be dt in place of x plus 1 by x into dx, and then x plus log x will be t square. This will be t raised 2 plus 1 divided by 2 plus 1, so t cube by 3 plus c. So in place of t you can write x plus log x whole cube, and 1 by 3 already there plus constant of integration. So this is how you are going to write it. So this is the way to write, because all these English, let, now, all these have to be done. X plus log x will directly give you 1 plus 1 by x. Next we have 10x, sec square x, 1 minus 10 square x. So if you take this, when you put this 10x as a t, this 10x will give you sec x tan x. So let's see what do we get. We will try to take this t equals to 10x. Now what is the benefit? Dt by dx will be sec square x dx. This dx will go on the right hand side. So this sec square x dx we already got. 10x was t. So this integration will become this t. Sec square dx already dt is there. Under root 1 minus 10 square x will be under root 1 minus t square. So again, solving this will again be some effort. But you know t square differentiation will be t or 2t. So we'll take t square as some y or some k or some p. So this is the double letting we are doing. So now this dp by dt will be equal to 2t, dp by 2 will be t dt. So this t dt is going to be equal to dp by 2, and under root 1 minus t square will be p. So it's the letting or assuming in two levels. So dp will be here, 1 by 2 will go here, dp by 2 actually, and under root 1 minus t square you can write just right. So there is a catch here. See, if we even take 1 minus t square as say p, that will reduce our effort. So here is a slight change. Rather than having 1 minus t square equals to p, I place t square equals to p. That will even complicate our issue. So now I'm showing side by side what was the error and how I'm trying to mitigate it. So dp by dt equals to minus 2t. I have taken 1 minus t square equals to p. Minus dp by 2 will be t dt. So this is negative dp by 2. dp is already there. 2 we have already written. Just negative sign has to be kept here. Negative half. Now t dt is already say negative dp by 2. But under root 1 minus t square is now under root p. Under root p. So we need to integrate the under root p. And under root p is some cp to the power half. When you integrate it, it will be p raised half plus 1 divided by half plus 1. So it will be p raised 3 by 2 divided by 3 by 2. This 2 by 3 will come when it goes up. So 2 by 3 into negative half, 2 gets cancelled, it will be negative 1 by 3. And this, I'm writing it directly. It's p raised 3 by 2. And what is p? P was t square, remember? So we will replace it by this negative 1 by 3. P was t square. So 1 minus t square was p. It's not t square. Previously I told you can write it as t square, but it has to be written as 1 minus t square. That was the mistake I committed. So 1 minus, now t is 10x, so 1 minus 10 square x to the power 3 by 2 plus constant of integration. This is the final result. So this is a wrong technique which I showed you on the left. 1 minus t square equals to p will make all your life easier when you solve this kind of questions if it ever comes in your examination. Now this result, when you put this t square equals to p, then this is the result which I actually not solved. I explained you the other solution. This is another solution, but the answer will remain same. Next one is log x. We have sine 1 plus log x whole square we have, and x is in the denominator. So 1 plus log x whole square, if you take it as t, let's see what do we get. T equals to, this will be 1 plus log x whole square. Now when we differentiate this is dt by dx. 1 will be 0, log x whole square will be 2 log x. And the differentiation of log x will be 1 by x. So log x by x we have got. That's what we wanted. And dx, log x, x is already there in the question. So all of these, if we equate, it is dt by 2. So when we have this dt by 2, integration will be half, you can take it outside, and dt. This I will become integration of dt, half you can take it outside, sine 1 plus log x whole square. So sine t it is. So integration of sine t you already know. It's negative cos t, half is already there, plus constant of integration. T is 1 plus log x whole square. Now replace this t by 1 plus log x whole square. So this is 1 plus log x whole square plus constant of integration. Negative half will remain like this. Now this is the way you are going to solve it. And if you just take this 1 plus log x whole square equals to t, all other things you know already. Now differentiation of 1 by x is directly negative 1 by x square. That you already know. So it's very easy to put this 1 by x as t. The differentiation dt by dx is going to be negative 1 by x square. Negative you can take on the left. Dx you can take on the right. So negative dt is equal to dx by negative dx by x square. Negative goes on the left, so it is dx by x square. So this integration is going to become like this. Negative goes out, dt remains here. It's cos square 1 by x, which is cos square t. Now cos square has a direct solution, that is cos square t can be directly solved, but we need to use the trigonometric identity here. So this cos square t or cos square theta is 1 plus cos 2 theta by 2. 1 plus cos 2 theta by 2. So we'll deal the negative later. 1 plus cos 2 theta by 2 can be written. So 1 by 2 plus cos 2 theta by 2. That's what you have to write. And since it is t, we'll integrate them separately. Negative, you can just put it here. Negative half is outside. I'm taking this half which is common in both the terms. I'm taking outside. Negative was already there. So negative half is outside. Integration of dt is t. Integration of cos 2t will be what? It's sine 2t. But we have to differentiate 2t and keep it in the denominator. So the differentiation of 2t will be 2 and it comes in the denominator. Plus constant of integration. Now what you have to do? You have to multiply everything by negative half. T will be replaced by 1 by x wherever it is. So sine 2 into 1 by x. So sine 2 by x you can write. This 2 is in the denominator but still my negative half is already there. So when you multiply this by negative half, this will become minus 1 by 2x. This will be negative 1 by 4 sine 2 by x. And this negative half into c will again become a constant because it's a constant only. So this will be the final result. This is the result I was talking about. 1 by x and then cos square t has to be written as 1 plus cos 2t by t. Now this will be sec 4x, 10x. Now this sec to the power 4 can be, it can be kept as sec 4 into two parts, sec square and sec square. Or you can do one thing. There is a different way of doing it. Integration will be sec square x into sec square as I was talking about. And then we have this 10x into dx. Now this sec square x is 1 plus 10 square x. Now once you get 1 plus 10 square x, you already have a 10x. Now you can take this 10x and keep it as t so that you can get the middle sec square x. So what I am suggesting is t equals to 10x we can write. dt by dx is going to be sec square x. dt will be sec square x dx. So this sec square x dx is dt. This whole is dt. And wherever tan is there, just put t over there. So t 1 plus t square. See, simple algebra now you have to do. Integration will be t. I am multiplying and writing t dt plus t square into t will be t cube. So t cube dt it will be. So this is going to be t square by 2 plus t raised 4 by 4 plus constant of integration. And t was earlier 10x. So 10x whole square by 2 plus 10x to the power 4 by 4 plus constant of integration. That's your final result. So this is the way of doing it. If you can separate this raise 4 power to 2 and 2 power, then this will become very easy because ultimately sec square x will be 1 plus 10 square x. Now this is a piece of cake for you. You know why? Because e root x is already we have, and differentiation of root x is 1 by 2 root x. So all the content which we want is readily available. So we can just place t equals to e root x. dt by dx will be equal to, this will remain same, e raised root x, and root x will be 1 by twice root x. Dx will go here, 2 will go this side. So 2 dt is e root x by root x into dx. That means this one and this one is already there, which is 2 dt. Now direct integration will be there. 2 you can take outside, dt will be there. It will be cos t because it's cos inside e root x, which is cos t. What is the integration? Cos t is sin t. 2 will remain there. In place of t, write e root x. So 2 sin e root x plus constant of integration. That's your final result. Now how are we going to write it? It's in front of you. You can try it yourself also. This question we are going to take in the next discussion. Till then, thank you so much and have a good one.